As children, we have to discuss today about an object which is moving with certain acceleration. For that, we have to take example what is acceleration. For that, if you are moving on the road with in the form of walking, or if you take the help of bikes or cycling, we are moving with certain speed. But that speed is not constant in each and every particular places. So whenever you have a smooth and comfortable road, we can able to increase the speed. When you have some up and downs like speed breakers or damaged road, ultimately we can able to apply the brakes, right? At that time speed is decreased. Simply, when increasing our speed or decreasing our speed, that we call change of speed. So when we have the change in the speed, that we call as acceleration, right? So if any object is moving with certain acceleration, so based on that acceleration, that moving object is having few equations. That equations we call as motion equations or kinematics equations. Kinematics means simply that can able to discuss with a moving object. Kinetic means that should be about a Greek word which gives the information about moving object. Right? Here we have to take first thing is distance or displacement is present. Already we discussed about this. Distance or displacement. So that we simply represent with S. Already in initial condition we discussed. When we use the principle of speed is equal to distance by time. So here notation of displacement or distance is S, and after that in starting of moving object we have initial velocity. Initial velocity or initial speed, that simply we represent with U, and on increasing of speed it can able to get final velocity. So final velocity we simply express it with V, right? And we have one more thing. As the speeds or velocities are able to change, it can able to passing some time. So the time period we simply express it with the T. And in the middle of that we have information about these all things changing of acceleration or not. Here acceleration we represent with A, right? We have S, U, V, T, A. And we have one more that already we discussed about average speed, right? So average speed means in the moving object it is having two types of velocities. One is initial velocity, another one is final velocity, right? So these two velocities average we simply call as average velocity. So that we can able to write like this, average velocity. So average velocity simply we express it with capital V, right? So these are the symbols or this particular information we are using in deriving of motion equations or kinematics equation, right? So once we have to take this particular information, and we should get how to derive the equations. In that we are having three different types of kinematics equations. First one, second one, and third one, right? So first we have to take the derivation about first kinematics equation, right? Have you got a clarity? Yes, children. Now we are discussing about the conditions for changing of speed, right? So in which time the speed of a particular object is getting changed. For that, if you take any uphill road, simply when you are able to move with the help of vehicles on a hill station, so we can able to get the road is like this. In initially, whatever the vehicle is there, it is having speed as more. Speed as more. So, if it is covers up to certain distance in a particular 10 seconds of time, right, with 100 meters of distance, then to cover one more 100 meters of distance, it takes not 10 seconds, it takes almost more than 10 seconds, right? So, as you to move up to the peak of the uphill road, it takes again more time. Means on moving of a particular upward road, the speed of vehicle is slowly decreased or not. Not only this, if you take the ball, if you are able to throw into the air, so initially it is having more speed. As it reaching to certain heights, at a certain height, it can able to stop again. It will hold for a fraction of seconds. Again, it will drop to ground. So same condition. On moving of uphill road, it is opposite to the gravitational force. For that, speed is decreases. So this is the one condition how speed is getting changed. Then one more, if you take any inclined condition or slope, inclined surface or what we call as slope. So if you release a particular ball from on the top of the slope, so initially it can able to cover least distance. In 1 second I consider 10 meters is covered, right? So in next second it covers almost 20 meters because the speed is getting increased from point to point. Then in third second it ultimately able to reach the bottom point. That indicates speed is increased. So these are the conditions what we see in our daily life about how speed is changed. So it is generally possible on uphill road and slope road or upward plane and downward plane or what we call as inclined plane. So these are the two conditions which shows a clear information about changing of speed, how it's possible. So that we call as conditions to know or conditions for changing of speed. Have you got a clarity? Now we have to discuss about first motion equation or first kinematics equation. It is based on acceleration. Acceleration what we call here simply change in speed by time. The rate of change of speed we simply call as acceleration. Then acceleration symbol we can able to represent with A. Moreover, change in speed. So what type of speeds or what type of velocity is there, that already we clear. We have initial speed and final speed. Like that, we have one more, initial velocity as well as final velocity. For that, here change of that we can able to write like this, v minus u means speed change, final speed and initial speed, or final velocity or initial velocity. That should be we have to divide with t. Then here t you have to take the change. So here acceleration simply we can write as v minus u by t. Then here take t to the left side. So here we can able to write as it is the product because these two are multiplied. Because here nothing value is present means that it is equal to simply a divided by 1. Right? So simply a by 1, that we simply cross multiplication, here t is multiplied with a. For that at is equal to v minus u. Then simply take this u to the left side, then ultimately we can able to write like this, at plus u is equal to v. That we simply call as v is equal to u plus at. So what is the use of kinematics equation? That from first equation. So the first equation simply derived from acceleration. Then what is the first motion equation or first kinematics equation? That is v is equal to u plus at. Means any object which moving with initial speed and acceleration is increased, and in a particular time of period we can able to find the final velocity. So the first kinematics equation is v is equal to u plus at. Have you got a clarity? Now we have to discuss about second motion equation that we call as second kinematics equation. That is simply we can able to write as speed is equal to distance by time. Right? So here speed we represent with v and distance with s, time with the t. So this relationship you have to write as equation number 1, right? Next we have to take average speed. So average speed already we are familiar, that is initial speed with final speed by 2. So average speed we express it with v, that is equals, and initial speed with the u, final speed with the v, that is equal to, right? So we have a representation. This one you consider as 2. So just compare equation 1 and 2, right? Simply, whatever the speed, average speed is there, you have to take consideration as equal. So these two v's you consider as equal, means same. Then ultimately these two values getting equal. For that we can write it like this: s by t is equal to u plus v by 2. Then you have to do one thing here, that is whatever the v value is there. So v value we know that u plus at, right? So this is the first kinematics equation. This one substitute in this equation you consider as 3. So then this is equation number 3, right? So whatever the u is equal to u plus at is there from first motion equation, that you have to substitute in this. So the v is there or not? Then the equation is changed like this: s by t, right? Then u plus v. First you have to write as u plus v. V means u plus at, right? Same thing you have to write u plus at by 2, right? Here you have to simplify that. U plus u, 2u plus at by 2. Then here you have to do cross multiplication, right? So when you apply the cross multiplication, simply s into 2 we can write as 2s, that is equal to 2u plus at into t. Then here you have to multiply t with this total term. Then 2s is equal to 2u into t and at into t. Then again 2s is equal to here 2u2 into t. Then 2ut plus at into t. Simply t into t we call as a t square, as from what we have power and exponential chapter in 8th class, that means starting. Then here simply whatever the coefficient is there here, right, take to the right side. Then s is equal, we can write 2ut by 2 plus at square, right? So here whatever the multiple number is there, that simply is divided the total equation. Then you have to separate it. S is equal to 2ut by 2 plus at square by 2. Then in separation, so s is equal, simply these two are getting cancelled. Then ut, then we can able to get as at square by 2. Then simply we can able to write like this: 2ut plus, take 1 by 2 is common, then we can able to write as at square. So here second equation of a moving object or accelerated object is s is equal to ut plus half at square. So this is the derivation of a second equation. Have you got a clarity? Now we have to discuss about the third motion equation or third kinematics equation. Further, here as like a second kinematics equation, first speed is equal to distance by time, right? That you have to represent with their respective symbols. Then consider as equation number 1. Again, you have to take average speed. That should be the value of initial and final velocities of speed by 2. Then you have to represent with their respective symbols. Then consider as equation number 2. Then compare the first and second equations. Then we can able to write s by t is equal to u plus v by 2. So that is you consider as equation number 3. Then we know that from first kinematics equation or first motion equation, we know that v is equal to u plus at. Then in that, simply we can able to write, take u to the left side, or simply we should take the acceleration condition. So here I am able to take u to the left side. For that we can able to write v minus u is equal to at. And take a to the left side, then simply it can able to change like this. Means time is equal speed changed by acceleration. V minus u, the difference in speed. A means acceleration. So the value of this is equal to time. In simply, so this is one type of consideration. If not, already we are familiar, acceleration is equals to speed by time. So simply we can able to that to change of speed. What we call change of speed. So change of speed we simply acceleration with a, change of speed means v minus u time t. Here just we have to interplace the a and t. For that we can able to write t is equal to v minus u by a. So in two ways we can able to get same equation. So what are the t value you got here? Simply t value substitute in equation number 3. Then this is equation number 3 or not? Then we can write s by t value is how much? V minus u by a. That is equal to u plus v by 2. U plus v by 2. Then on cross multiplication, this is changed like this. So when you take this one to the right side, u plus v and u minus v by a. Here you have to take 2a as LCM. S is equal to, if you take 2a as LCM, we can able to write u plus v and u minus v. Sorry, v minus u. Right? It is simply like a mathematical application, what we call a minus b into a plus b. We can write as a square minus b square. Same like here also we can able to write s is equal to v square minus u square by 2a. Then take 2a to the left side, then ultimately it can change 2a into s v square minus u square. Then this one will simply change like this. V square minus u square is equal to 2as. So this is the equation of third kinematics version, or third equation which an object moving with certain acceleration. That is v square minus u square is equal to 2as. Moreover, this equation does not include any time factor. So here no t terms are there. First one is having t, time is existed. Second one also s is equal to ut plus half at square. In that first and second equations we have time factor, but in this time factor is not included. So without having of time also we can able to get the acceleration, whatever the displacement or distance we covered, initial velocity, final velocity. These are all things we can able to calculate. Right? This is the clarity about the first, second and third equations when object is moving with certain acceleration. Okay children? Children, now we are going to discuss about circular motion. Simply, it is explained like an object which is moving on a circular path, that we call as object is in circular motion. Further, in our daily life we have plenty of explanations or what we call examples. If you take vehicles, that vehicles are moving on the road on rotation, right? So until you change the gear, the speed of wheel is same. If you change the speed, ultimately the speed of rotation is increased. In same way, we can see same type of circular motion in our house, especially to the fans, either ceiling fan, table fan. Including within kitchen, we are using grinders, mixers, right? So in that all, we can able to see the parts are is moving in particular circular path. At that time, if you not able to change the speed or the object is moving with the same speed in each and every time period, then we call speed is constant. Speed is constant. So when speed is constant on a circular path, such type of motion we call as uniform circular motion. Means the object is moving with the same speed on the circular path. That indicates uniform circular motion, right? At that time, so here what happened? Simply, if you take this particular circle or circular path, it is the combination of plenty of line segments. Plenty of line segments. Then, due to that reason, right? So every small segment we call as displacement. What we call? Displacement. For that, the circular path we simply call a set of polygons, right? As a result, when this particular speed of the object is constant, then it is having a small segment or not. Then when an object is covered shortest distance in straight line, that we call as velocity, right? Then here one condition, in uniform circular motion, speed of the particular object is constant, but in every particular shortest distance of line segments, the velocity is ready to or getting changed. So that simply we can represent like this. So these all arrow marks is showing velocity of particular object which is moving on a circular path with uniform motion. Then this one we call as velocity vector. Velocity vector. So always means once the object is removed at any point, it can able to moving in a straight line path like this. So these all lines are arrow marks we call as tangents. So the tangents we call as velocity vectors to the object which is in uniform circular motion, right? So have you got a clarity about this condition, especially this particular speed terms and velocity terms in the condition of uniform circular motion? It is very, very important. Once you got a term as uniform circular motion, the object speed is constant, because in every time period, so to finish one rotation, it takes same time. Best example, one more, I not yet mentioned, that is if you take hands of the seconds or seconds hand, minutes hand, hour hand in the clock, it is having same covering distance. Moreover, to complete that entire rotation, it takes same time. For that should be uniform circular motion. Moreover, rotation of Earth, rotation of all planets, moreover, revolution of Earth. These all should be best example for uniform circular motion. Moreover, in that the speed of the particular object is constant, but velocity is changed. Moreover, whatever the velocities are changed, that simply we express it with the velocity vectors with like this. Here arrow indicates direction. Moreover, velocity vectors is always vector quantity, but speed is scalar quantity, already what we discussed in the earlier class. Right? Have you got a clarity?